Hey guys, and welcome back to another video on the channel. In today's video we're going to be taking a look at the 2020 Math Methods External Exam Paper 1 Question 13 short response. Now you would have noticed with all the exam questions I have started taking a look at them in individual videos. Pretty much that way I can go into a bit more depth on each question, and if you only struggle with a couple questions you can go to those ones in the actual video, not the video on the channel. The full exam video is still up on YouTube, so you can still check that out. But otherwise, let's get straight into it. If you need a Math Methods External Exam Bundle Pack, the link is in the description below, and there is a discount code special with this video here. They'll only apply to 10 people, so go check it out. But otherwise, let's get straight into it. So, 13. A function is defined as f of x equals x times log x all squared for x is bigger than 0. The graph of the function is shown and has a local maximum at a point A and a global minimum at a point B. The derivative of the function is given as f dash of x equals 2 ln of x plus ln x all squared, still for x is bigger than 0. So first of all, they've broken this question up into a couple parts, and the total marks here is 7. So here, verify that there's a stationary point at x equals 1. So here. Now, first of all, a stationary point means the gradient is flat, aka the derivative is 0. So for the first bit here for A, they want us to verify when I chuck in x equals 1 into the derivative, you get a value equal to 0. So even though it's only worth 2 marks there, it's really important we show as much working as possible. So what we would show here is we would go, alright, we just write the derivative out first of all. So like this here. Make sure you use the derivative, not the actual function here, because otherwise you'll still get 0 if you use the actual function just because it's at that coordinate there. However, that won't be the correct thing. Okay. So here, now we just chuck in x equals 1. So wherever there is an x, you're going to put a 1. Okay. So here, we'll have 2 ln of 1 plus ln 1 all squared. Now, this has to be done without a calculator, so you should already know that ln of 1 or log of 1, doesn't matter what the base is 0. So here what you would show is 2 times by 0 plus 0 squared, so you get 0. Hence we verify that x equals 1 is a stationary point. So that should give you your 2 marks there. Okay, pretty easy question to start off with, but again, hopefully you remember that ln of 1 or log of 1 is 0, otherwise it would be a bit trickier to verify it. Okay. Alright, B. Determine the coordinates of A. Now, a very sneaky thing they've done is usually each previous question depends on the question before it. Now, question B doesn't, because a lot of people would be like, oh, we've got the value of x, let's just chuck that into the original to get the coordinate of A. However, that's the coordinate of B. You've got to work out exactly what the coordinate of A is, and we don't even know the x value for that. However, we have been told that it has a maximum there. We can see it from the graph. So at the coordinate A, f dash of x is also equal to 0. So what you want to do is you want to work out, alright, what other x values for your first derivative make this function equal to 0. So here, all we do is we write out that first derivative, which they've given us, and all we've got to do is go, alright, what values of x make this guy equal to 0? So we're going to replace that with 0. So you get 0 equals 2 ln of x plus ln of x all squared. Now you might be wondering, how do we start solving this? Well, in my opinion, if you start rearranging it, you will come into some issues because you're going to miss some important attributes. I would say the best thing to do is factorizing these two guys here, so see what's in common. Now, at first glance, it might be a bit tricky to work out, but hopefully you can see that both of them have a log x in common. There are 2 of them on the right-hand side, and there's 1 up here. So if you factor it out, well, let's go back to the red color. I prefer the red. So 0 equals 2, oh, not 2, we'll just factor out the ln. So just write ln of x, open bracket, and then here what would be left there is 2 plus, and then just another ln of x. Okay. Now, because you have 2 things multiplying to give 0, what that means is you can write 2 equations. You can write 0 equals ln of x or you could write 0 equals 2 plus ln of x. Now one of these guys here should give you x equals 1 because that is also a stationary point. So we have this guy and we have this guy here. This one here is most likely for that guy here, which implies probably this one is most likely for that guy there. Now the reason why I can tell is if you look at this equation here to the furthest to the left, if you were to rearrange this to write it as an exponential, you would get e to the power of 0 equals x. Anything to the power of 0 is 1, so you get x equals 1, which is the coordinate b. So we don't really need that in this question here because we're trying to find a. So this one is most likely coordinate a. You would probably still keep that working. I've just rubbed it out because I'm running out of room. Here, you would move the 2 to the other side, so you have negative 2 equals ln of x. Now, if you're wondering how I rearranged that first equation just before, what we've got to understand is you can switch from an exponential form back and forth to a logarithmic form. Now, the reason why we're switching between the two of them is because our unknown is inside the log, so we want to go from this format to this format here. Now, ln is a log base of e, so we would write this as e to the power of negative 2 equals x. So that is the x value for coordinate a. However, they've said the coordinates of a, which implies you need the y value as well. So what we do with that is we substitute this into the original function because you need to work out what that y value is. And the original function, I'll just get rid of this stuff here because we're going to run out of room otherwise. If you need that working, just rewind the video. So here we take this guy and we're going to chuck it into the original function which they've given up here. So x ln of x all squared. So here you're going to work out f of e negative 2. So wherever you see that x, you're going to replace it with e to the power of negative 2. So you'll get e negative 2. Then you'll have ln of e negative 2 all squared. Now you might be wondering, how do we further simplify that? Well, we don't apply the squared straight away. We look at the log, okay? So first of all, we can recognize that ln is log base e. And if you have log a of a, so if they're the same number, it'll give you 1. And you can also realize you can take that outside the front of the log. So what we'll do is we'll take that outside the front of the log first. So we'll write it as this, negative 2 times by ln of e all squared. We can recognize that cancels to 1. So we have negative 2 times 1. And then if we square that, that will give us positive 4. So what you're left with is e negative 2 times by 4. Therefore, you're left with 4e negative 2. So that is your y value, which means the coordinate of a would be, now, the image I've put here, there are a lot more lines are working as well. I've just cropped it so I can fit on the Word doc. But what you would put here is coordinate a is e negative 2, comma, 4e negative 2. That's the coordinate of a. Alrighty. Again, if you have any questions about this one here, leave something in the comments and I'll try my best to answer it. But let's get on to C now. So, the graph of the function has a point of inflection at x equals e to the power of p. Determine p. So a point of inflection is when the gradient is at a maximum steepness between some local, well, between two stationary points. Now here, we've just worked out these are the only two stationary points on the graph. So the only point of inflection will be in there, halfway between there. Which means that's when the second derivative is equal to 0, a point of inflection. Now there might be another one, however, this one I imagine may not work because you can't chuck in x equals 0. So we may get two things here, but we'll be able to work our way through it. So first of all, we write the first derivative, and because we haven't been given the second derivative, we're going to have to differentiate this guy here. So if we just write like this, I'm just going to move this whole thing just up there. So let's differentiate this guy. So here, if you were to differentiate the first term, the 2 doesn't change because it's just a constant, okay? And it's multiplying this. We're just differentiating the log, which would turn into 1 over x. And then we go plus. When we're differentiating the last term here, we can recognize it's a chain rule because you have an inside function, which is the log, and an outside function, which is the power of 2. So here, you would differentiate the outside, so it's going to be 2 times by ln of x to the power of 1. Then when you multiply it by the differential of the inside, which is 1 over x in this case. Great. Now what we'll do is we'll tidy that up a little bit. So we'll just write it as 2 times by 1 over x plus 2 over x times by ln of x. Now the reason I wrote it like this is hopefully you can see, oh actually, I didn't write it completely how I wanted it. 2 over x. Hopefully you can see both of these terms have something in common. We're going to factor it out. Factorization is your best friend in the non-calc exam. It'll make the algebra a lot easier. So if I factor out 2 over x, what I'd be left with is 1 plus ln of x. Now if I set this equal to 0, I'm going to get 0 equals 2 over x, 1 plus ln of x, and here we're going to be able to break this up into two equations, okay? Now the first equation will probably give us something unknown. This is most likely for this guy here, which isn't defined because you can't chuck in x equals 0, okay? And that's just a whole mess there because you get 0 equals 2. So that one is undefined. It doesn't make sense. It's trying to work out when 0 would intersect with a hyperbola, which doesn't make sense. The other equation you get is 0 equals 1 plus ln of x. Now to get the x by itself, you move the 1 to the other side. So negative 1 equals ln of x. Rearranging from a log to an exponential, you'll get e to the negative 1 equals x. Now the question was here, the graph of the function has a point inflection at x equals e to the power of p. We've got something here. We've just said it's x is equal to e to the negative 1. Therefore, your p-value must be negative 1. So negative 1 is the answer to question C. Is this a hard question? Yes and no. It's a hard question if you don't know what a point of inflection, a stationary point is, and how to differentiate. Other than that, it's pretty easy. The only thing that might be a bit troubling otherwise is the algebra and all the weird numbers. But again, you should be expecting this on the non-calc paper. Okay. Now, if you had any questions about this one here, leave something in the comments. Otherwise, if you want the external exam bundle pack with a discount code, link is in the description, only works from this video here. But otherwise, I will see you in the next video.